This video is on the trapezoidal rule. Some functions cannot be integrated exactly. In these cases, the area needs to be estimated, and that's what we use this rule for. In the trapezoidal rule, the area is split into several trapeziums by using lines parallel to the y-axis, as you can see there in that diagram. The interval from x equals a to x equals b is divided into n strips. The width of each strip is found by this formula, h equals b minus a over n. The actual trapezoidal rule with n strips is this. So we have our integral. So the integral from a to b of f of x dx is approximately half multiplied by h. Then we have this in brackets, and when we do an example, you'll see how all that works. This formula is in your formula booklet too. We are going to do two examples to show how we can use the trapezoidal rule and how we can use it with an equation and also in a real world context. Example 1, use the trapezoidal rule with 4 strips to estimate the integral from 1 to 3 of 1 on x dx. Obviously here we have an equation. We could find the exact value of this area by using our calculators, but sometimes you may be asked to do it this way instead and to find an estimate. And I'll show you how to do that. The first thing in this situation is we need to find the h value, our width of each strip or each trapezium, which will be h equals the top boundary 3 minus the bottom boundary 1, all over how many strips, which is 4, and this equals 0.5. Once we've done that, we're going to create a table. And in our table, our top row will be just x, and our bottom row will be the equation. And that will be 1 on x in this example. We start at 1, and we got by our h value each time until we get to our top boundary. So this would be 1, 1.5, 2, 2.5, 3. And you would always have one more number than how many strips, because each end of the strip we also include. From here, we sub each of these x values into our equation of 1 on x and get that solution. And if we do that for each of these numbers, we would get 1, 2/3, a half, 2/5, and 1/3. From here, I'm just going to label these. You don't need to do this, but it'll just help being the first time we're using this rule. This would be y0, y1, y2, y3, and y4. From here, we have all the information to be able to put it into the rule. We wanted to estimate the integral from 1 to 3 of 1 on x dx. Then we use our squiggly equal sign, and we use the formula. So the formula here, I've just underlined it in purple just above. It starts off with a half multiplied by h. Our h is 0.5. Open brackets, we have y0 plus yn. That is our first and last values from our table. So in this case, it would be 1 plus 1/3, our first and last numbers, plus 2 times all the numbers in the middle of the table added together. 2/3 plus a half plus 2/5. Put that straight into your calculator and we'll find the approximate area would be 1.12. Okay, so it's knowing here the 1 and 1/3 here are our first and last values. Then the 3 middle numbers are the numbers in the brackets that we multiply by 2. And that is how we use the trapezoidal rule. Now the next example is a real world context where we don't have an equation. A geographer measured the depth of a 5-metre wide river at 1-metre intervals. Use this information to estimate the area of the river at this point. First of all, we need to figure out what h is. And that's just our intervals that we took our data, which in the question tells us is 1 meters. And you can also see here in the table, the first column goes down by 1 each time. Therefore, our h is 1. And then the second column is all our data. So that would be y0, y1, y2, y3, y4, and y5. And we can just put this straight into our equation. Now we don't have anything to write first, so we can just write the area is approximately and put everything in. It's a half times our h, a half times 1, multiplied by the first and the last value from the table, which will be 0 plus 0, plus 2 times all the values in the middle. 1.3 plus 1.5 plus 1.9 plus 0.8. Then you just put that into your calculator and you will get an approximate area of 5.5 meters squared. And that is how we do the trapezoidal rule.